Okay, today we're going to start reviewing for our test that's going to be over relations, functions, graphing. So the first thing we're going to do is practice solving for y, because it's a very important skill to have in doing this, and it'll be very important in our next unit also. So you find the y and you want to get it by itself. So we're going to have to get rid of the 3x and the 4. Remember, try to get rid of everything added or subtracted first. So we're going to subtract 3x from each side. Do that, we get 4y equals 12 minus 3x, because we cannot simplify this because they're not like terms, so we just have to write it like that. Again, y is being multiplied by 4, so to undo that we're going to divide by 4. Get y equals 12 minus 3x over 4. 4 does not go evenly into both these, so this is how I would suggest you leave your answer. Now if you do want to simplify, since it goes into one of them, you can write that, but just don't forget to write the second one, even though it doesn't go in there. You got to leave it as that. So 12 divided by 4 is 3, and 3x divided by 4, or 3 divided by 4, we would write like this. But I, again, would prefer that you just write it that way, I think, so if you don't make any mistakes then. Again, here's our y, so I need to get the opposite of subtract 7, which would be add 7. That gives me x plus 7 equal 2y. The y is not by itself. I need to divide by 2. Neither one of those are divisible by 2, so I just write x plus 7 over 2 equal y. If you want to turn it around, you can. Doesn't really matter. Continuing on with doing the same thing, I want to get the y by itself, so I got to get rid of the 4x. So I'm going to minus 4x, because it's a positive 4x from each side. Be careful here, it leaves you negative y equal 9 minus 4x. So the y is not by itself, it's like has a negative 1 in front of it, so I'm going to divide everything by negative 1, which really just changes the sign. So the 9 becomes negative, and the negative 4x becomes positive. So you can leave it like that, or if you do want to turn it around, that would be fine. 4x minus 9, either way would be fine. Again, here's my y, so I want to get rid of the 3, so I subtract 3 from each side, and I get 1/4 x minus 3 equal y, and I would be done. Okay, we're going to move on now and talk about an arithmetic sequence. Remember, that's when it goes up by the same amount every time, so you got to determine the pattern. So ask yourself, what do I do to 22 to get 17? 17 to get 12. 12 to get 7. What is the pattern that we're using? Looks like it is subtract 5. So we're going to continue that pattern. If we take 7 minus 5, we get 2. 2 minus 5, we get negative 3. And negative 3 minus 5, we get negative 8. So those would be the next three numbers in the sequence. In order to write an equation for this table, we got to find the pattern that's happening here. So if you look here, what are you doing to negative 3 to get 0? You're adding 3. What happens going from 0 to 3? You're adding 3. Here you're adding 2 and adding 2. Remember, it's always going to be the y over the x, so we're going up y coordinates by 2 and x coordinates by 3. So we're going to put that in an equation and then test it, and if it doesn't work, then we'll have to do some changes and add something or subtract something from that. So using the same x values, I'm going to just put them in this equation and test it. So I put a negative 3 right in here. It's going to be 2/3 times negative 3. Remember how you can cancel. That gives me negative 1. It gives me negative 2. If I put a 0 in, 2/3 times 0 is 0. If I put a 3 in, it's going to make that positive 1, which will make that 2. So I need to ask myself, what do I do to this number, negative 2, to get the 0 that I wanted to get? What do I do to 0 to get the 2 that I wanted? Well, the pattern is that I have to add 2. So that's how I have to adjust my equation. So my equation would be y equals 2/3 x plus 2. If I stick these x values in, I will get these y values that I was given. So now it would work. Next it says to solve this, so remember the solving is going to be a set of ordered pairs, so you can either write it like the set containing and have several ordered pairs. I prefer using an XY table, just understanding that the XY is an ordered pair. This is the domain, so that goes under the X, which is the first coordinate, remember, and then you just put the numbers in and do the math to see the Y, since it is solved for Y. That's why we want to solve it for Y. It makes our work easier. So if I put a negative 2 in here, 2 times negative 2 is negative 4. Negative 4 plus 3 would be negative 1. Again, just kind of go back and put a negative 1 in. 2 times negative 1 would be negative 2, plus 3 would be 1. Maybe we can do the positives in our head. 2 times 1 is 2, plus 3 would be 5. 2 times 2 is 4, plus 3 would be 7. So these would be our ordered pairs, and you can leave them in a table. Is this a function? This is a yes or no question, so we have to see, is everything of the domain paired with exactly one range? So 4 is paired with 2. Looking through everything else, is it paired with anything else? No. 3 is paired with negative 6. Is it paired with anything else over here? No. 2 is paired with 2, and 5 is paired with negative 1. So they're all paired with exactly one thing, so it would be a yes. And now, remember, this is just an evaluation of a function. It gives us our function, f of x equal 2x minus 4, and we want to find f of 7. So where there's an x, I'm going to replace it with a 7. So it's going to say 2 times 7 minus 4. 2 times 7 is 14. 14 minus 4 is 10, and that would be my answer to evaluating that function.